Okay, welcome back to another video on the Maths channel. It's your teacher, Ms. Lim here, and in this video we're going to be looking at some past HSC questions with a particular focus on bearings. So let's have a look at this first question here. This is from the 2006 paper, question 13. What is the bearing of A from B? Now the very important part of this question is the word from. So when it says from B, that means we're starting of B. I'm going to go in a clockwise direction until we hit the line that's associated with A. So we want to know how big that is. Well, I know that tells us that this is also 60 degrees because alternate angles are equal on parallel lines. And therefore, this bearing here has to be 300 degrees because 300 plus 60 is 360. So the answer is D. By the way, feel free to pause the video at any time and attempt these questions before I go through it. This is question 4 of the 2019 paper. Which compass bearing is the same as a true bearing of 110 degrees? So what I'm going to do is I'm going to draw 110. I know that that's 90, so 110 is probably about there. 110 degrees. So in order for us to work out our true bearing, I know that this is north, east, south, west. This line here is in southeast, so it's southeast. So we're going from south. We're going from south to east. South to east. I want to know how big that angle is. Well, we know that this is 180 degrees. So 180 minus 110 is 70. So this has to be 70 degrees. So the answer is C. Okay. Question 7 of the 2018 paper. The diagram shows the positions of towns A, B, and C. Town A is due north of town B, and angle CAB is equal to 34 degrees. What is the bearing of town C from town A? Okay, from town A means we're going north of A, clockwise direction until we hit town C. Well, because we already know that this bit here is 34, we know this is a straight line, so that's 180. So the bearing has to be 180 plus 34. 214. C. Question 10 of the 2010 paper. A plane flies on a bearing of 150 degrees from A to B. What is the bearing of A from B? So this time, from B, north of B, clockwise direction until we hit that line. Now, because this is 150 degrees here, I know this has to be 30, because this angle sum of straight line, which means that this bit here has to be 30 because alternate angles are equal on parallel lines. And therefore, the bearing of the orange angle here, the whole thing, has to be 360 minus 30, has to be 330 degrees. So the answer is D. Question 20 of the 2012 paper. Town B is 80 kilometers due north of town A and 59 kilometers from town C. Town A is 31 kilometers from town C, and all of that information is represented in this diagram. What is the bearing of town C from town B? From town B, so north of B, clockwise direction until we hit the line that's associated with town C. So I want to know what that bearing is. So in order for me to do that, I will probably need to work out what this angle here is, and then do 180 degrees minus that. So it looks like I will need to use a cosine rule. So we know cosine C is equal to A squared plus B squared minus C squared all over 2AB. Okay, that's on your formula sheet. where C is the angle that we need to work out, and this little c, or this lowercase c, is the side that's opposite that angle. So the side that's opposite that is 31, so that's lowercase c. Doesn't matter which other sides are a and b, order doesn't matter. So I'm just going to write that in. Cosine of theta is equal to a squared, I'll just say a is 80, plus 59 squared, minus 31 squared. The important one is what you're minusing, all over 2 lots of 80 and 59. So the angle therefore has to be the inverse cosine of all of that. And let's see what we get when we put that in our calculator. 80 squared plus 59 squared minus 31 squared over 2 times 80 times 59, which is 19.11. Okay, so that means this angle here is 19.11. So therefore, this has to be 180 minus that, which is 160.89. So it looks like the closest one is C, 161 degrees. Okay. Question 25 of the 2016 paper. The diagram shows towns A, B, and C. Town B is 40 kilometers due north of town A. The distance from B to C is 18 kilometers, and the bearing of C from A is 25 degrees. It is known that angle BCA is obtuse. What is the bearing of C from B? Okay, so it already tells us what we need to work out. We know that this angle here is obtuse. So it seems like we need to work out how big this angle is. Maybe we'll call this alpha. And then we can just do 180 minus that to give us the bearing. It also seems like we need to work out how big this angle is. Then we can just do 180 minus that, minus the 25, because we've got a triangle here, and that'll give us alpha. In order for us to do that, it seems like we need to use the sine rule. So I'm going to say sine of angle C over 40 is equal to sine of 25 over 18. Remember, we need to pair them up with whatever's opposite. So sine C has to equal to 40 sine 25 over 18. So C has to equal to the inverse sine of that. Which is 69.9 degrees. So this is 69.9. Therefore alpha has to equal to 180 minus that, and also minus 25 because we've got a triangle, and all three angles in a triangle will add to 180. So 180 minus that minus 25 gives us 85.1 degrees. So now we can work out the bearing. We know that that is 85.1. Therefore, bearing of C from B is 180 minus that. $94.9. which is about 95 degrees, so the answer is B. Now, just so that you know, for bearings, it must always be 3 digits. So if it's less than 100 degrees, make sure you put a 0. So if this was not a multiple choice question, make sure you write 095 degrees, not 95 degrees. Okay, this is not a bearing. Right, question 17 of the 2008 paper. The diagram shows the position of Q, R, and T relative to P. In the diagram, Q is southwest of P, R is northwest of P, and angle QPT is 165 degrees. What is the bearing of T from P? So it seems like from P means north of P until we hit T. We actually want to work out how big this angle is. Let's have a look at this information again. Q is southwest of P, so I might just draw in this here on my compass rose. Because Q is southwest of P, that means that this angle here has to be 45 degrees. And because R is northwest of P, that means this angle here has to be 45 as well. Well, so are these. That's 45. And this is 45. Alright, so now that we know that, this is 45 down here, and this bit here is 90 degrees. What does this one have to be in order for these 3 angles to add to 165? So we have 45 plus 90, which is 135. So this one here has to be 30 degrees. And therefore, our bearing has to be 90 minus 30. That has to be 60 degrees. 060 degrees. Right, question 23 of the 2014 paper. The following information is given about the locations of 3 towns X, Y, and Z. X is due east of Z. X is on a bearing of 145 degrees from Y. And Y is on a bearing of 60 degrees from Z. Which diagram best represents this information? So let's start off with the first one. X is due east of Z. So that one's fine. This one's not. That one's fine. And this one is not. Okay, X needs to be east of Z. Alright, that one's done. X is on a bearing of 145 degrees from Y. So from Y means we're starting north of Y. That needs to be 145 degrees. Well, we can't really tell at the moment. I don't think that that's 145. Actually, we might be able to. Because this is 60, this has to be 60. Okay, alternate angles. Which means, therefore, that this bit here has to be 145 minus 60, which is 85. So, if we do 180 minus 85, will that give us 145? No, it won't. So, it can't be A. So the answer must be C. Let's just double check. This one here is 60, because this one's 60, so that. This one here has to be 35 degrees. And therefore, this one has to be 145 degrees. Because 145 plus 35 is 180. So the bearing of X from Y is 145. That one works. And Y is on a bearing of 60 degrees from Z. So from Z, yep, that is correct. So the answer is C. Alright, I think now we're moving on to some short answer questions. So that's it for the multiple choice questions. Question 30, part C of the 2017 paper. The diagram shows the location of 3 schools. School A is 5 kilometers due north of School B. and school C is 13 kilometers from school B, and angle ABC is 135 degrees. Calculate the shortest distance from A to C to the nearest kilometer. So pretty much we want to know how long that is, how long AC is. So we've got 1, 2, 3 sides and 1 angle, so we need to use the cosine rule. So AC squared is going to equal to 5 squared plus 13 squared minus 2 lots of 5 times 13 times cosine of 135. I might just want to work out what AC is straight away, so I'm just going to square root all of that in one go. And let's see what we get. (16.91). This is to the nearest kilometer, therefore 20 kilometers. Right, part 2. Determine the bearing of school C from school A. From school A, so north of A, clockwise direction until we hit C. So I already know that this bit here is 180 degrees, so really I need to work out what this is. Then I can just add that on. In order for me to do this, I will probably use the sine rule. Seems like that's opposite the 13, and the 135 degrees is opposite the 20, which we've already worked out. I'm just going to use that answer 20 from part 1. Instead of the 19 point, sorry, it's not 19. I made a mistake. This should be 16.91, so 17 kilometers. So I'm going to use 17 instead. Alright. So because we are working out an angle, I'm going to have the angle at the top. So sine theta over 13 is equal to sine 135 over 17. So sine theta is therefore equal to 13 sine 135 over 17. So theta has to equal to the inverse sine of all of that. (32.73). I'm just going to write 7 degrees. (32.7). Therefore, the bearing of C from A is 180 plus that. 212.7. To the nearest degree, 213 degrees. I'm just going to show my working out. 180 plus 32.7. Nearest degree. Alright, question 27a from the 2002 paper. In the diagram, X, Y, and Z represent the locations of 3 towns. The town Y is due east of X, and the bearing of Z from Y is 46 degrees. So the bearing of Z from Y, so north of Y, that there is 46 degrees. Find the size of angle XYZ. Okay, well, because this is this bit here, that has to be a right angle because Y is due east of X. So this has to be a right angle. So the size of angle XYZ is 90 plus 46, which is 136 degrees. I'm going to put that in right now. Find the distance XZ, correct to one decimal place. So now that we've done that, we can use the cosine rule because we've got 3 sides and 1 angle. So I might do that to the side over here, question 2. So xz squared is equal to 18 squared plus 22 squared minus 2 lots of 18 times 22 times cosine of 136. But I'm just going to square root that to get the answer straight away. So that's going to give me 37.1 kilometers. Alright, and part 3. What is the bearing of y from z? From z means we're starting north of z, clockwise direction until we hit the line for y. So really what we need to do is work out this angle here, and then we can do 180 plus that. Okay, well before we worked out that this here is 46, so therefore this has to be 46 because alternate angles are equal on parallel lines. So the bearing has to be, for part 3, from z is 180 plus the 46, which is 226 degrees. Alright, question 27C of the 2005 paper. The bearing of C from A is 250 degrees. C from A, so we know this here is 250 degrees. And the distance of C from A is 36 kilometers. Explain why theta is 110 degrees. So part 1, theta equals 110 degrees because 110 plus 250 is equal to 360 degrees. Angle sum at a point. Alright, part 2. If B is 15 kilometers due north of A, calculate the distance of C from B, correct to the nearest kilometer. So calculate this distance. So we know this is 110 degrees. So again, we're just going to use the cosine rule. So I might just add in a little extra space here. So we want BC is going to equal to the square root of A squared plus B squared minus 2AB cosine C. (15 squared plus 36 squared minus 2 times 15 times 36 times cosine of 110 is 43.5. This one says to the nearest kilometer, so I'm just going to say 43 kilometers. Okay, question 27, part B of the 2009 paper. A yacht race follows the triangular course shown in the diagram. The course from P to Q is 1.8 kilometers on a true bearing of 58 degrees. So this has to be 58 degrees because it says from P, so we're starting north of P. At Q, the course changes direction. The course from Q to R is 2.7 kilometers and angle PQR is 74 degrees. What is the bearing of R from Q? R from Q, we need to know how big this angle is, and then we can add the 74. So in order for us to do that, I'm just going to extend this compass rose here. I know that this bit down here is 58 degrees because alternate angles are equal on parallel lines. So that means this is technically 180 plus 58 plus the 74. So the bearing of R from Q will be all of that. 180 plus 58 plus 74, 312 degrees. I like to do capital T for true. Part 2, what is the distance from R to P? So we want to work out how long this distance is, which means we'll be using the cosine rule again because we've got 3 sides and 1 angle. So I might do that to this side here, part 2. RP is equal to the square root of A squared plus B squared minus 2 lots of A, B, cosine C. (2.7) squared plus 1.8 squared minus 2 times 2.7 times 1.8 times cosine of 74. 2.8 kilometers. Alright, the area inside this triangular course is set as a no-go zone for other boats while the race is on. What is this area of the no-go zone? So in order for us to work this out, the area of this triangle, we're just going to use the formula, which is area is equal to half AB sine capital C, where A and B are the two sides that are surrounding the angle C. So this is our angle, 74 degrees. So the two sides are 2.7 and 1.8. So we've got half times 74, not 74, times 2.7 times 1.8 times sine of 74. Which is 2.34 square kilometers to 2 decimal places. Alright, let's have a look at question 24C of the 2011 paper. A ship sails 6 kilometers from A to B on a bearing of 121 degrees. It then sails 9 kilometers to C. The size of angle ABC is 114 degrees. So it looks like I need to add these key pieces of information to this diagram. From A to B, there's 6 kilometers on a bearing of 121 degrees. Then sails 9 kilometers to C. The size of angle ABC is 114. Alright. What is the bearing of C from B? C from B. So we want to work out how big this angle is. In order for us to do that, we need to work out how big this one is. And then we can just do 114 minus that. Now this one's not going to be too difficult because here we've got co-interior angles. And co-interior angles are supplementary on parallel lines, so they add to 180. So this one here has to be 180 minus the 121, which is 59 degrees, because these two angles will add to 180. Well, that's 59. This one here has to be 114 minus 59. Has to be 55 degrees. Therefore, the bearing has to be, because it's a bearing, we need 3 digits, 055 degrees. True. Part 2. Find the distance AC. Give your answer correct to the nearest columnar. So if we were to draw in that line, AC, again I'm going to be using the cosine rule. So part 2, AC is going to equal to a squared plus b squared minus 2ab cosine c, 114, because that's the big angle that's opposite the side we're finding. But we need to square root all of that. Which is 12.7. Now the question says to the nearest columnar, so I'm just going to round it to 13 kilometers. And part 3. What is the bearing of A from C? So from C means north of C, we're going to go in a clockwise direction until we hit the line for A. Give your answer correct to the nearest degree. Okay, so the first thing I would do is I would probably extend this compass rose down here. And because this bit here is 55 and alternate angles are equal, I know that this bit here is 55. I know this bit here is 180. So all I really need is I need to work out that bit. And then I can just add all three of them together. So how am I going to do that? Well, I know that that angle there, let's call this angle theta, is opposite the 6 kilometers. And I know that the 114 degrees is opposite AC, which we already worked out as 13 kilometers. So I'm going to use the sine rule. Sine of the angle over 6 is equal to sine of the angle over 13. So theta has to equal to the inverse sine of 6 sine 114 over 13. Okay, I brought the 6 to the top, and then to get sine theta by itself, and to work out the angle, I took the inverse. So let's put that in our calculators. Inverse sine of 6 sine 114 over 13 is about 25 degrees, because we want the nearest degree, so I'm just going to say 25 degrees. And therefore, the bearing of A from C is 180 plus 55 plus the 25 which is 260 degrees. Alright. Question 26 of the 2007 paper. 2 more questions. The diagram shows information about the locations of towns A, B, and Q. It takes Alina 2 hours and 48 minutes to walk directly from town A to town Q. Calculate her walking speed correct to the nearest kilometer per hour from town A to town Q. So she's traveling 15 kilometers and it's going to take her 2 hours and 48 minutes. So all I'm going to do is I'm going to divide 15 by 2 hours and 48 minutes. And that gives us 5.36. Now to the nearest kilometer per hour, I'm just going to say that that is 5 kilometers per hour. Alina decides instead to walk to town B from town A, and then to town Q. So she wants to walk this way first, and then to town Q. Find the distance from town A to town B. Give your answer to the nearest kilometer. Okay, so town A to town B, we've got a triangle here. We're going to be using the cosine rule again, because we've got 3 sides and 1 angle. So I'm going to do that up here, part 2. AB is equal to 15 squared plus 10 squared minus 2 times 15 times 10 times cosine of 87. I'm going to square root all that. And that gives us 17.6 kilometers. And the question says, give your answer to the nearest kilometer. So I'm just going to say 18 kilometers. Alright, part 3. Calculate the bearing of town Q from town B. Q from town B means north of B until we hit Q. So really we need this, and then we can add 180 to it. So I'm going to split this one up, because I know whatever this one is, it'll be the same as this. And in doing so, I've noticed that we've got, maybe I'll just highlight in blue, we've got this, co-interior angles. We know co-interior angles add to 180. So that means this bit here has to be 180 minus the 149, 31 degrees. So that's 31. This bit here has to be 87 minus 31, which is 56. Therefore, this one's 56. And therefore, the bearing has to be 180 plus 56. $236 degrees. True. Okay, last one for this video. This is question 26b from the 2003 paper. In the diagram above, the following measurements are given. Angle TAB is 30 degrees. Let's put that in. B is 50 meters due east of A, and the bearing of the bearing of T from B is 20 degrees. The bearing of T from B is 20 degrees. Copy or trace that into your answer booklet. Explain why angle ABT is 110 degrees. So we know that this is a right angle, as B is due east of A. I'm going to introduce a new letter here, N for north. Angle ABN is 90 degrees. Therefore, angle ABT is 90 plus 20, which is 110 degrees. Last one. Long video. Calculate the distance BT to the nearest meter. We want to work out this length here. Let's see, what can we do with this one? Well, because I know that this angle here is 110, I might put that in. That's 110 degrees. Which means that this angle here has to be 180 minus 110 minus 30. So what's 1/4? That's 40 degrees. So if I want to work out this length, I'm going to use the sine rule, because I know that 40 is going to pair up with that 50, and this 30 degrees here is going to pair up with the side that we're trying to find. So bt over sine 30 is equal to 50 over sine 40, because that's what it pairs up with. So bt therefore has to equal to 50 sine 30 over sine 40, which is 38.89. This says to the nearest meter, so 39 meters. And that's it for this video. So we've just gone through a whole bunch of different questions that are focused on bearings that have actually appeared in past HSC papers. I hope you found this video helpful. If you did, please give it a like and subscribe, and I will see you in the next video. Have a good day.